Yes. Coming to the formulae for radius of curvature, the formulae are like this. When the curve is in the form y is equal to f of x, the formula is the formula for rho is 1 plus y1 square whole power 3 by 2 by y2. Y1 is nothing but dy by dx. Y2 is equal to the second derivative of y with respect to x, or d square y by dx square. Now, if the curve equation is of the format x is equal to f of y, then how will rho be is, rho would be nothing but 1 plus x1 squared whole power 3 by 2 by x2. What would be x1? It's the derivative of x with respect to y, first derivative. X2 would be second derivative of x with respect to y. Okay. Now, usually, guys, no curve would be given in the format of x is equal to f of y. Okay, it is for us to find out. So, there's an important note here which I want the students to keep in mind. That is what that note is. Usually, in the first case, in case one, or in the formula one, when I am finding out y1, or while when finding y1, that is nothing but dy by dx. Suddenly it so happens that at some point, at a point p, dy by dx goes to 0. In such a case, what I will do is my mind should switch to the formula of the second case. That is, immediately what I should do is, immediately listen to this carefully. I have got dy by dx to be 0. No, just a second. If I have got dy by dx to be infinity, guys, when I have got dy by dx to be infinity, what happens when I put in in row? What happens is infinity. Radius of curvature would go to infinity. So immediately my mind should switch to the formula or the curve equation to be x is equal to f of y format, and go with dx by dy. Go with dx by dy instead of dy by dx. Agreed? Right? I won't go with dy by dx. I'll go with dx by dy. Now, in this case, dx by dy at that point would go to 0. 0 is fine to handle, but infinity is difficult to handle. Things will become improper, or L'Hopital's rule should come into picture if it is in one of the indeterminate forms, and so that's why I'll be using the second formula in the case where I have dy by dx to be infinity, guys. Okay. Yes. This is about the formula. Let's do one problem on radius of curvature so that you understand the concept. Okay. There are some standard formulae which are very much asked by the examiners. Okay. Now the question is, find rho at any point of the curve. The curve is of the curve y is equal to c cos h x by c. Okay, guys, we know the formula anyways. I'll just go with the default formula, or default that y is equal to f of x is my curve. Okay, if anything happens which becomes problematic by getting infinity, then I will shift to the other second case. Otherwise, usually by default, I go with the first case only, or the first formula only. Dy by dx, I'll be trying to find out cos hx derivative. As all of you know, cos hx derivative is sin h. Sin hx derivative would be cos. Hyperbolic functions, sin and cos will never go to 0, right? Will never go to negative. Sin h x by c. Now, there's an x term as well, and I am differentiating with respect to x. So, I should be differentiating x by c as well. X derivative is 1. So, I'll be getting 1 by c into 1 by c. Sin h x by c is what I will get. Okay. So again, I will be going to find out the second order derivative, that is d squared y by dx squared. Okay. As I have said, sin h derivative is cos h derivative is sin h. Like sin and cos, there are no negatives. Okay. Yeah. Cos hx by c. X by c derivative would be 1 by c. Right. Now we will substitute this in the formula rho. What is rho? 1 plus y1 squared whole power 3 by 2 by y2 squared, right? Y2, that's it, not y2 squared. Okay. So 1 plus y1 squared would be what? Y1, I have, this is my y1, this is my y2, right? Y1, I have got it to be sine h x by c. Okay. So I'll be adding 1 by sine h square x by c whole power 3 by 2 by, I'll be having cos h x by c. There's a by c, denominator by denominator goes to the numerator, right? Yes. Now I'll be expanding. 1 plus sine hx squared would be cos hx squared. Okay? Yeah. This one would be what? Cos h squared x by c whole power 3 by 2. And there is a c as well here which has come from the denominator. Cos h x by c is what I have. This square and this 2 goes off. I'll be left with cos h cube x by c by cos h x by c. Okay. So again cube and 1 goes off. So I'll be left with what? C cos h square x by c. This would be my radius at any point, guys. Radius of curvature at any point P. If I'm given the specific point, at that point I'll be evaluating, right? Okay. This is how I will solve, which is very easy, though it's scarce, it's very easy. Okay.